All right. So greeting YouTube, beautiful mind here. So we are entering the home stretch. First of all, I'd like to say I hope everyone had a great weekend. Happy National Star Wars Day. So may the 4th be with you. Okay. Let's see. So we have just about 2 weeks of time left in this quarter. Okay, this is a very interesting quarter. You know, with the social climate of everything that's going on, you know, it's one of those things. It is what it is. You just have to do your best, forget the rest, don't stress, and be blessed. I hope everyone had a great weekend. You were able to get outside on some level and soak up the sunlight. To me, the sunlight, nature and trees, the wind and the air, fresh air, all of this stuff just helps. Like with what what we deal with as humans, especially being in academia. Nature helps. So I definitely encourage people to get outside on some level as much as possible. Hopefully we're eating a certain kind of way and, you know, staying active. That kind of stuff helps too. It makes a difference. So I think this will be, I think I'm gonna go ahead and let this be the last of the new material. Okay. So section 6.4, we'll take some time to look at it and do the best that we can. I want to say I went on and loaded the remaining all assignments for the remainder of the quarter, okay, including the final exam. So I'm giving you like about 2 weeks to do these things. We just had exam 3. Also, I reduced the late penalty from 20% to 10% for all assignments. So all assignments from the beginning to the end should be available with at most a 10% late penalty. So what that means is if you really want an A on an assignment, you could get it. If a B is good enough, you could get that too. If a C is what you want, you could get that. If a D is what you want, you could get it. If an F is what you want, you could get it. Whatever grade you want, honestly, you could get it. It's just a matter of, you know, it is a lot of work, you know, so since I'm not really doing extra credit, my way of accounting for not doing extra credit, I make assignments available early with unlimited attempts all the way up until Saturday, May, I think the 16th. So not this Saturday, but next Saturday, everything is going to close up because assignments have to be submitted, grades have to be submitted. The only thing that might be available past Saturday, May 15th or 16th, whatever that day is going to be the final. I want to keep the final available until the end of our last day. So if this is a Monday, Wednesday, Friday class, that Monday after that Saturday, May 16th or 15th, I need to look and see what date that is. May 16th, right? So that's that Saturday. Saturday is the May 16th, 17th, 18th. So Monday, May 18th is our last day. So if we end class, like 125? So that's the last thing that is going to be available is the final, and that's going to be the last assignment that I'll accept. Okay, so all assignments for the entire quarter are available. I don't really plan on loading any more new assignments. This is the last of the new material, and I'm available. I have at least one student in this course. We've been going back and forth, and it seems like they're getting it. Like they're asking pertinent questions. Like it's clear that they've been going through the material. Okay, not to say that others aren't, you know, but it is reassuring as your professor to get that feedback and know that someone on some level is getting it. So, you know, I know that we're not all the same. We have like a lot of the same base structure as far as needing to eat and sleep, bleeding blood, and all that kind of stuff. But if one person can do it, that means others can do it. It's possible, at least, you know. I don't know why I love water so much. It's so delicious to me. It's like, especially when it's delicious water. I know I'm saying water, but waters be having different tastes. You can taste like impurities and like you can get a sense of the different containers, especially when it's coming through pipes. Oh, that's the worst. Anyway, but yeah, so and then so announcements, let me see. So all assignments are loaded into Pearson, unlimited attempts with a reduced late penalty from 20% to 10%. Be sure that on Moodle that we've completed the participation and honesty quiz. Also, there is an assessment that's on Moodle, okay? So these 2 things on Moodle will serve as quiz grades, so you just want to be sure to get those submitted. I can't think of anything else. I'm here. If you have questions, it's been a great quarter, okay? And yeah, all right. So let's take some time to look at this this section here. Okay, so we'll continue in chapter 6 with section 6.4, confidence intervals for variance and standard deviation. Okay. So some objectives here are how to interpret the chi-squared distribution and use the chi-squared distribution table, how to construct and interpret confidence intervals for population variance and standard deviation. So the point estimate for population variance is S squared, right? And the point estimate for the population standard deviation is S. So S squared is the most unbiased estimate for the population variance. The estimate population parameter. So for the variance is going to be sigma squared with the sample statistic is going to be S squared. So is that the sample variance? The population standard deviation is sigma with the sample statistic is going to be S. Okay. So we can use a chi-squared distribution to construct a confidence interval for the variance and standard deviation. If the random variable x has a normal distribution, then the distribution of chi-squared equals to n minus 1 times s squared over sigma squared forms a chi-squared distribution for samples of any size, n strictly greater than 1. All chi-squared values, chi-squared, are greater than or equal to 0. The chi-squared distribution is a family of curves, each determined by the degrees of freedom. To form a confidence interval for chi-squared, use the chi-squared distribution with degrees of freedom equal to 1 less than the sample size. So again, degrees of freedom is just going to be 1 less than the sample size. The total area under each chi-squared distribution curve is equal to 1. The chi-squared distribution is positively skewed, and therefore the distribution is not symmetric. Okay, so the chi-squared distribution is not symmetric. Chi-squared distribution is different for each number of degrees of freedom. As the degrees of freedom increase, the chi-squared distribution approaches a normal distribution. Okay, so as the degrees of freedom increase, the chi-squared distribution approaches a normal distribution. Okay. Let me see something really quick. I want to go back. Confidence interval for the variance and standard deviation. Yeah. In my mind, I imagined the student saying, "Well, what is a chi-squared distribution?" And then so I was just checking for myself. Here, we can use the chi-squared distribution to construct a confidence interval for the variance and standard deviation. Okay. But anyway. So there are two critical values for each level of confidence. We have chi-squared R and chi-squared L. So chi-squared R represents the right tail critical value, and chi-squared L represents the left tail critical values. All right. So these charts are going to tell us the area in the curve to the right of our chi-squared critical value. Right. Whether it's the left or the right, it's going to tell us the area under the curve to the right. Okay. So then we can conclude that the area between the left and right critical values is going to be C, and to find that we would subtract the two. Okay. Okay. So in this example, we're asked to find the critical values chi-squared R and chi-squared L for a 95% confidence interval when the sample size is 18. Okay. So the degrees of freedom, again, is going to be n minus 1. In this case, 18 minus 1 is 17. So with that degrees of freedom, each area in the table represents the region under the chi-squared curve to the right of the critical value. Let's see. So, we will use the tables. The area to the right of chi-squared R is going to be 1 minus C over 2. So if we want a 95% confidence level, right, 1 minus 95, so it's going to be 0.025. So then the area to the right of chi-squared L, let me see. So the R was 1 minus C over 2, and the L is 1 plus C over 2, is 0.975. Okay, so then we will use the table. So this is in the back of our textbook, right? Degrees of freedom. We see on the left, we have 17 degrees of freedom. The area to the right of chi-squared L. So you cross the degrees of freedom with the area to the right, and we see the critical value. We get the two critical values of 7.564 and 30.191. So from the table, we can see that the critical values of chi-squared R is at 30.191, and the chi-squared L is at 7.564. All right. So for a chi-square distribution curve with 17 degrees of freedom, 95% of the area under the curve lies between these two critical values. Okay. So then if we want a confidence interval for the population variance, we would use these two formulas. N minus 1 times S squared over chi squared R and L in this fashion. This is for confidence interval for the population variance. Confidence interval for the population standard deviation, we take the square root of all three parts. Okay. So the probability that the confidence interval contains the population variance or the population standard deviation is C. So that's the confidence interval. Assuming that the estimation process is repeated a large number of times. Okay. So constructing a confidence interval for variance and standard deviation, in words, verify that the population has a normal distribution. Then identify the sample statistic N and the degrees of freedom. Okay, so how many elements are in that sample, and then use that to determine the degrees of freedom. Find the point estimate, S squared, so that's like the sample variance. And then find the critical values chi squared R and L that correspond to the given level of confidence. Use table 6 in appendix B. Okay, so for chi squared, for constructing confidence intervals for the population variance and standard deviation, we're going to use this chi-squared construction and table 6 in appendix B. Okay. Find the left and right endpoints to form confidence intervals for the population variance using these formulas that you see on the right side of the screen. Okay. And then find the confidence interval for the population standard deviation by taking the square root of each endpoint. Let me see something. Okay, we've seen all this. Okay. All right, so let's look at this example. So on constructing confidence intervals, we randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation is 1.2 milligrams. Assuming the weights are normally distributed, construct a 99% confidence intervals for the population variance and standard deviation. Okay, so we see that our N is 30. If we want a 99% confidence interval, so then we would have to do for chi squared R and chi squared L, we have what? The plus or minus C thing, right? It's here it is, 1 minus. Area to the right of chi squared R is going to be 1 minus C over 2, which is 0.005. And the area to the right of chi squared L, 1 plus 0.99 over 2 is 0.995, right? So then when we use the chart in the back, that will give us, we have our degrees of freedom. So we have what, 30? So 29 degrees of freedom. And the 99% confidence level. So then the critical values that come from the chart are here. Then we have to use those formulas for the left and right endpoints. So when this is repeated a large number of times with a 99% confidence level, we could say that the population variance is between 0.8 and 3.18. Cool, that's exactly what I just said. Milligrams, the only thing I was missing. Okay, and then if we want the population standard deviation, we take the square root of all parts. Okay. We could check our answers using technology. Say we were using Minitab, we have this. I don't have access to Minitab. I'm sure I can find it. I'm pretty sure we can also probably do this in like numbers in Excel. I'd have to look into it, right? Okay. So I really didn't want to do much more than that. Okay. So that's really the material that I'd like to go through for the quarter. We actually did a little bit more than what I typically do with the students. And the reason I'm okay stopping here is because like if we were in person, a lot of days where we did lecture this quarter, we wouldn't have done lecture because we would have been doing an exam or, you know, something of that nature, or taking time for other things. But since we are at home and we have way more time, contact time, then we were able to go a little bit further. Okay, so just to kind of recap, so one, I am available for questions. Okay, so hopefully you all are taking advantage of the setup here. The main thing is you want to go ahead and maximize your scores. You get unlimited attempts at all assignments. The late penalty is 10%, so if you really want an A, it's there, just sitting there waiting for you. I think the final exam is loaded. Exams 1, 2, 3 are there. I think exam 3 was due this past Saturday. I did go ahead and update the grade book, so I would check Moodle, and if grades don't look like, if anything is missing, you need to reach out to me. I do intend to kind of go through and reach out to students that are like at risk, okay? Because I think this is the last week to withdraw, so I will probably reach out. Happy National Star Wars Day on Moodle. Be sure that we've completed the participation and honesty quiz, and there's an assessment that's on Moodle as well, so be sure that we've completed that as well. I can't think of anything else, so on that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.